you are preparing to begin your PhD at Concordia University with
Exactly.
quantum computing this fall.
Exactly.
Um, how does this compare? Like, what kind of problems are you exploring, or how do you see your research evolving? What's exciting you about this research this fall?
Okay, so my research with Professor Shapiro has really shaped my mind on how to approach quantum computing research. I don't have to just think about doing the work scientifically, but after doing it scientifically, how I should push it further to see how it can be applicable to the real world. So, for instance, what I'm going to do in Concordia University is on spherical harmonics, and then this is an application to quantum chemistry. So, diverting a bit into quantum chemistry. So basically what they are doing is that with their quantum chemistry, like this spherical harmonics, like it provides solution to the orbit of the electrons around the nucleus. And then basically currently what they have is that they have Cartesian grid to solve these orbits of the electrons around the nucleus. But when you think about the Bohr model, for instance, we know that the orbit of the nucleus is round. So if it is round, just applying Cartesian coordinates will be a bit tedious. So we are trying to implement spherical coordinates that is incorporating spherical harmonics to solve the orbit of the nucleus for computational use. And then this could be also applicable to make quantum chemistry more efficient, especially in solving the motion of the electrons around the nucleus. So then this is one of the things that I am going to deal with to develop the algorithm to solve the orbit of the electrons around the nucleus using spherical harmonics at the background. So then that is basically what I'll be doing. And then I'm also thinking about how I can push this research further on applying it to industry, especially quantum chemistry is mostly used in drug deliveries and then mostly also used in battery. So I've been thinking about how I can push it further into these areas of application. So that is one thing that I've been thinking about.
When you say you look at spherical harmonics, is that you prepare a specific type of ansatz to do some VQE algorithm to approximate the ground state, something like that?
Exactly.
I see, yeah.
Exactly.
And have you thought about the problem of because usually the Hamiltonians for this type of molecule they're very long. So what you do is you get the Hamiltonian of the molecule, then you apply Jordan-Wigner to transform it into the qubit basis, and then you have a lot of terms. So that means that you need
Exactly.
to run a lot of circuits,
A lot of
right?
exactly.
So
Exactly.
what
So these are some of the problems that I'll be tackling. So then
mhm,
um so that is why these are some of the problems that I'll be tackling to build the algorithm for it. So basically currently we have the
mhm.
VQE and then the VQ LS, and then all these things to solve the Hamiltonian for the ground state. So then basically like I'm yet to think about how I can build the algorithm to which will be efficient in the field of the quantum chemistry. So that is in the basic direction that I'll be going.
Yes, because once you like figure out like how many terms you have to evaluate, there's this problem like the click problem, right?
Yes,
Like how many terms of the Hamiltonian can you measure at the same time? But
exactly.
given the terms of the Hamiltonian, solving that problem to see how many circuits you need to run is
Yes.
NP hard,
Yes,
right?
that is that is something that I'll be encountering. So yeah, I'm aware
Yes.
of that. So yeah,
Okay.
I've been thinking about it, how to get all these things done, like when I start in fall 20 this September.
Okay. Do let me know if you solve that problem. I will be
Sure,
really interested. Yes.
sure.
That sounds so fascinating. Any last words from yourself?
Okay, so I would like to work in the industry where I will apply my knowledge in the research field to solve problems related to quantum computing and then how they are being applied in the industry. So I would say that currently like open like when I start my PhD, I'm open for internships in IBMs and then also in quantum computing company, any startup that would want to, that's interested in my background and then would want to work with me, open for any internship opportunities and then any opportunity in the industry to also apply my knowledge that I have gathered so far in quantum computing to solve any problem they have. So this is something that I'm really, really hoping to get.
Thank you again, Michael. This has been incredibly insightful. We're really excited to share your work and perspective with the broader audience. I'm excited to see any collaboration between you and Marco.
Yes,
And
I'll be
yeah,
expecting that.
yeah. And thank you for taking the time to speak with us, especially from us here at Cuba, from the Cubo perspective. We really appreciate your time.
Okay. I also appreciate and then thank you, Luna, and also thank you, Marco, for this opportunity to also speak with you and then exchange knowledge.
Yeah.
I'll reach out to you so that we can publish paper together.